Welcome to my YouTube channel. On this channel, I'll be talking about everything related to artificial intelligence, the advancements, the developments, and the recent buzz that is there of DeepSeek. So I try to go through the paper of DeepSeek and understand what is it all about. And in this video, I'll be discussing the same. So before DeepSeek, there was another world that existed, which was of traditional large language models. So let's try to recap that and how does it work, okay? So we all know that our traditional large language models have been trained on humongous amount of label data, and that is what we call as supervised learning when we are doing the model training using label data. While in DeepSeek, they are trying to incorporate the reinforcement learning driven reasoning through the model, and that is how the DeepSeek would stand out. How, why, the details we would be seeing a little later in the video. So a few minutes and we would have a recap at how the architecture of OpenAI language model would look like, particularly the training part. How would that model have been trained? So the rough architecture is somewhat like what you can see on the screen. So we have a pre-trained base model which was trained on large data set. Okay, we used that to have our fine-tuned model, and this fine-tuning was done using human annotated data. The examples could be like your question answer data, your text and summary data. So these kind of data were used to develop our fine-tuned model. Let's call this as SFT, supervised fine-tuned model. Okay, so and why do we generally do fine-tuning, or what is the purpose of having a fine-tuned model as next step? Because fine-tuned model helps in doing specific tasks in a better way, and it also enhances the quality of responses that the model can give. So that is how fine-tuning helps. That becomes our second step. Post that, what you see is that we have the reinforcement learning from human feedback. So here there are multiple steps. We will look at each one of it. Now the SFT model is prepared. When the prompt is passed to that model, the model would generate multiple responses. Each of these responses would be evaluated by the humans and would be ranked from best to worst. And these human evaluated data would become the training data for our reward model. Again, what is a reward model? So whenever we are talking about reinforcement learning, we know that when the model does good, we give it a positive reward. When the model does bad, we give it a penalty. That's how this reinforcement system works. So we need to have a reward model which would understand that whenever there is a right answer or right reasoning, let's give more points. If it is bad, decrease the points. That's how it would develop the reasoning capability. Okay, so coming back, so we are using the human evaluated data for training the reward model. And once the reward model is trained using the human feedback, the next step is to fine-tune the language model using reinforcement learning. Okay, now you would see that there is in the section fine-tune model with RLHF, PPO is there. So PPO stands for proximal policy optimization. It is a type of reinforcement learning algorithm. As of now, we'll stop till here for the definition of PPO. The details, the mathematics, everything behind it, we would be talking in the next video. Okay, so what is happening is that this PPO is helping in fine-tuning the model to maximize the rewards, not just by picking the best response each time, but also by capturing the wrong responses. Why? Because this would help the model in analyzing and understanding that these are the failure cases, and this is not how you have to think. So this would also help the model in becoming better and more accurate in the future. Okay, so this is how our RLHF works here. Now you could understand that this is an iterative process, but does it mean that the human evaluation is needed all the time? No, human evaluation is not needed all the time. Our trained reward model would be replacing the human evaluation after a while, and it would be used to fine tune the language model so that the language model learns to give maximum reward, maximize the reward for the prompts that it is getting, for the responses that it is getting for each of the prompts. Okay, and that is how our OpenAI language model would be finally ready. So this was just the recap, and the idea of this recap was to make you understand that in the traditional LLMs, we rely heavily on the supervised fine-tuned model and the proximal policy optimization for our reinforcement learning. Okay, but in the DeepSeek, how things are different. So in DeepSeek, we have two versions that we would be looking at. One is DeepSeek-R1.0, the second one is DeepSeek-R1. So DeepSeek-R1.0 was introduced before, and what they had done there was that they just added reinforcement learning on the base model, which is DeepSeek v3 version, and they did not use any supervised fine-tuning model. This itself was a very aha moment for them as per their paper, because they are not using any supervised data here. They are letting the model reason on its own and learn on its own that what is right, and do the evaluation, re-evaluation, and accordingly give the output. Parallelly, they also replaced the reinforcement learning algorithm, which was PPO in the OpenAI. Instead, they are using GRPO, which is generalized reinforced policy optimization. Okay, and they, because of all of these things, they also had eliminated the human and labeled data that they needed, human and evaluated data that they had needed. Instead of that, they have introduced the rule-based rewards. Okay, so this way they are ensuring that the reasoning is accurate and the language is consistent and so on. Let's have a quick glimpse of how DeepSeek-R1.0 would look like, the architecture. So they have taken DeepSeek v3 base model, done the reinforcement learning without any labeled data. So the model is doing a lot of self-evaluation, self-reasoning, re-evaluation, and then giving us the final DeepSeek-R1.0 model. So the good thing with this is that yes, the rethinking is happening, and we are using GRPO optimization because it is more scalable, it is more computationally efficient. Also, let me tell you that PPO and GRPO, the two types of reinforcement algorithm, would be covered in the next video because it is a big topic in itself. For now, let's just know that these two are different types of reinforcement learning algorithm. Okay. All of that is fine, but there were still challenges with output. What were the challenges? So the first was that the reasoning that it was doing, the model was doing, was it would end up mixing languages. So it would not always be just in English. There would be other local languages also, and that would end up giving a not so good experience to the users all the time. The second thing was that the formatting of the reasoning and the output was not so good, and a user would end up kind of struggling to read the output properly. So these were the challenges, and to mitigate them, they developed DeepSeek-R1. Okay, now with DeepSeek-R1, first thing that they did was that they decided to add cold start chain of thought data. So they decided to give a cold start to the model by doing a supervised training on the based model using chain of thought data. What is chain of thought data? It is like a reasoning data. Okay, like the way we reason, that kind of after this what happens, after this what happens. So that kind of very high quality data they prepared and used it to do the training of the base model. This was not done in our DeepSeek-R1.0, but don't confuse it with the supervised fine-tuning that was done on OpenAI. Why? Because that was using a lot of data, while this is using very less data compared to the OpenAI supervised training. Okay, so they use this data. Now also, because this is a chain of thought data, which means the reasoning data, they ensured that the formatting was well. Okay, so you use XML formatted data. For example, the prompt tag is there, the think tag is there, the response tag is there. So this way, the model learned how to give the output, the way the data should be structured, the way output should be structured, and it helped in handling our language, the output structure problem, readability issues that we were facing with the DeepSeek-R1 Okay. This alone, the cold start with chain of thought data alone gave a very good result compared to the R10. Okay, the next step that was done was the reinforcement learning with the GRPO. Now this is almost same as what was there in the DeepSeek-R10 model, just that here they also added one more reward, which is language consistency reward, because we had seen the issue of language mixing. So to handle that issue, they added this reward that if the language is consistent, give more rewards. Okay, and this again made our readability better. The third step is the rejection sampling and supervised fine tuning. So when the so whatever is the output generated by our reinforcement learning algorithm, that was ranked, and only the one with the best ranking, with the best response for the given prompt, was passed for the supervised fine tuning. So by now you would have understood that there are two times we are doing supervised fine tuning. One was done at the initial step as part of cold start. The second one is this. At this step, in this SFT phase, we are also adding the initial data that we had used and the high quality response for each of the prompts. But you can think like, why are we doing two times? Okay, because now this would again be, this SFT model as fourth step would also go through the reinforcement learning. So why are we doing it two times? It is because the first time that we had done having a fine-tuned model and doing the reinforcement on it was handling our reasoning part. Okay, it ensured that the model reasons the question properly and rethinks, reevaluates. While this part where we are doing the rejection sampling and then doing the supervised fine-tuning, this ensures that our model capability in terms of writing, the role playing, and the general tasks that are there, it does that properly. Okay, so basically to make our model output more user friendly, more versatile. Okay, and then finally that also finally we do the reinforcement learning tuning again of the supervised SFT model, so that our human preferences are taken care of. We can enhance the helpfulness in the answer. There should not be any harmful stuff in the answer. The reasoning should be more robust. So that is the idea, to make it more like, ensure that it is more generalized. Now this diagram that I'm showing you here is just showing the architecture of DeepSeek-R1. As we had discussed, you can see that there is a DeepSeek v3 base model. On that, we have done the fine tuning using the chain of thought data, and then there is a reinforcement learning that happens. Post that, whatever is the response of the reinforcement learning, the rejection sampling rejects all the unnecessary or not so good response, just takes the best answer for each of the prompt, passes it to the SFT along with the initial cold start chain of thought data. It kind of mixes both the data and then does the reinforcement learning again on this our final data, and that's how our DeepSeek-R1 model gets ready. So this is the training process of how DeepSeek-R1 data was trained. We saw that there were 2 times that the reinforcement learning step was happening. We understood that the first was to ensure that the reasoning capability is incorporated well. The second was to ensure that we have captured the human preferences well. The answer should be in the proper, more readable format, should be able to do the domain specific tasks well, and the output should be, the response should be like more helpful, less harmful, all of that. Okay. Now our DeepSeek-R1 model is ready. We have seen how it works, but let me also tell you that the performance itself is amazing. The way DeepSeek-R1 is doing as of now is, it has become one of the best models. I would suggest all of you to give it a try. Also, the good part with DeepSeek team is that they have made the entire thing open source and also provided distilled models. So what is distilled model is that we have the larger model that we already saw, DeepSeek-R1, that is trained in so many multi-stages, and there are so many billions of parameters in that model, but using that on every system would be difficult. So what they have done is that they have fine-tuned the other open source models like Quen and Llama using the output of our DeepSeek-R1 model. So they have taken like 800k curated samples from DeepSeek-R1 model, fine-tuned the existing open source models like Quen and Llama, and prepared the distilled model, okay, which can be used by you and me for our work. Now the good part with this is that this smaller model, you might think that it would perform lesser, right? But that is not how it is. Why? Because it has now, the best part is that it has all the good reasoning, the high quality reasoning capabilities of the bigger model, the DeepSeek-R1. It has inherited all of that, and also the size, the training parameters are lesser here, the size is lesser, so it is very efficient to use these smaller models. And it would be very good to see what more can come out of this, how people are utilizing it. So with that, we have seen how DeepSeek has changed the whole game of traditional AI, traditional LLMs by incorporating a lot from reinforcement learning and eliminating the human dependency completely. And the way human thinks, the reasoning capabilities has been incorporated in a very good way. Now, for those who could not understand as of now what was happening, let's also take a look at the layman explanation of DeepSeek-R1 versus DeepSeek-R1. Now imagine there are 2 chefs who are learning to cook. First chef is the DeepSeek-R1 guy, who would decide that I don't want to read the recipes, I don't want to go through the videos, I don't want to watch or know anything beforehand. Let me just go into the kitchen and do the experiment by trying different ingredients, by doing different processes, and then in the process I'll taste and see what works out. The good part with this approach is that this guy might end up creating something completely unconventional and out of the world recipe. The bad part is that it can be completely bizarre sometimes also, okay? For if they are not knowing human tastes, they can completely forget to say add salt altogether. So this was DeepSeek-R1 for you. The DeepSeek-R1, on the other hand, this chef likes to study different recipes. He decides to watch different videos, be full prepared, understand how the human tastes are, like based on the feedback that this recipe can be too spicy if I add so much of pepper to it, if I add so much of salt to it, it can be too salty. So based on feedback, this chef has learned a lot, and also based on a lot of study that he has done. The good part with this is that this chef understands what human wants, what human likes eating, and would try to incorporate that taste. Okay, and that is why this would not give any bizarre results or bizarre dishes to the users. So this is how your DeepSeek-R1 and DeepSeek-R1 is different. You would understand that DeepSeek-R1 would be more reliable because it is trained, and the initial training that we have talked about, the thousands of cookbooks or watching YouTube tutorials, is the remember the cold start thing, right? We're giving a cold start to the model with chain of thought data. So this is the data that we are giving, and making it giving it the data to tune itself, to do the supervised fine tuning on the model, so that it knows and understands human preferences well and does the reasoning properly. So yeah, this is what it is, and we have a few more terms just for reference purpose, and few links that can be used to understand the DeepSeek model well. With that, thanks.